So it appears that my video that I made about the problems with quantum mechanics and how they claim that light is a particle or behaves like a particle, and if you do a quick search on for evidence that light is a particle, you get these two reasonings right here: the photoelectric effect and the double slit experiment. So the photoelectric effect is when light hits a metal surface, it can cause electrons to jump out of the metal. This effect was discovered in 1887 by Heinrich Hertz, who noticed that ultraviolet light produced the effect more strongly than lower frequencies. Albert Einstein, who got the Nobel Prize for the photoelectric effect, used the photoelectric effect to develop the particle model of light that suggests light moves in packets of photons, or massless particles called photons. Each photon carries a specific amount of energy, and the experiment shows that the kinetic energy of the ejected electron depends on the frequency of the light, not its intensity. For example, some frequencies of light don't cause any electrons to jump out of the metal at all. Okay, so there's a video that is an old army video now that actually shows what is going on in the photoelectric effect. What we have here is an old army video. Now in this video they actually show the experiments happening, like the real experiments, but they also show these computer generated videos of it as well, which I don't mind them having as long as they show the real experiments too. You can't just have these cartoon like things with as your evidence of anything in physics. You got to have the real experiment as well in your video to prove what you're saying is real.
To this astonishing conclusion, we are led also by experiments on the conduction of electricity through gases. Ordinarily, gases are non-conducting. Electricity normally does not leak off charged wires in direct contact with the air. Likewise, an electroscope will hold its charge almost indefinitely. If, however, a flame is held near a wire attached to the electroscope, the leaves collapse at once.
Okay, so you notice right there it said that if a flame is held close to a wire connected to the device, that then the leaves collapse as well. So if a flame is made up of mostly infrared light, it's mostly heat coming off the flame, right? And there's a little bit of yellow light, maybe a little bit of orange light. I mean, that's all low frequency light. And yet it was still able to make the leaves collapse if you brought a flame close enough to it. Now they're going to show what happens when you have ultraviolet light or X-ray light shined on the device at a distance.
Similarly, X-rays produced even at some distance cause the charged leaves to collapse. We can explain these phenomena if we assume that the flame and the X-rays caused air molecules to become charged, some positively and some negatively. With a positively charged electroscope, negatively charged molecules are attracted to the knob and cause some of its charge to be neutralized. Furthermore, when the electroscope is negatively charged, positively charged molecules present cause the leaves to collapse. When the X-ray tube is turned off, these charged molecules called ions are no longer formed. Those remaining neutralize each other, and thus the air again becomes a non-conductor.
Okay, so you understand that? Did you catch all that? He says that when the X-ray light is on, it causes the gas around the apparatus, the particles in the gas around the apparatus, to become charged positively and negatively. So no matter what charge that you give the apparatus, whether it be positive or negative, the positive and negative charges that is now activated in the gas around it will now neutralize the charge in the apparatus. It's not the light waves or coming in as a particle and striking the metal like a billiard ball and knocking off electrons out into space like like if it was a billiard ball, you know what I mean? It's not how this is. That's not what's happening in this experiment. The gas that's around it is what's discharging it. Now, if they say that the low frequencies of light are not able to do the same thing, then why is it when the person takes a flame to it, it discharges it? He charges it up, whether it be positive or negative, but then if you take a flame, which is low frequency light, which is orange, red, infrared light, and if you take a flame to a wire that's connected to the metal apparatus, it'll also discharge. See? They're showing the real experiment there. So low frequency light does cause this to discharge. It's just not low frequency light that comes from artificial sources. You have something like a flame, it'll also discharge it. So this shows the proper way of looking at the photoelectric effect. And this way of looking at it is not. And surprisingly, Albert Einstein got himself a Nobel Prize for explaining the photoelectric effect in this manner. And if we agree to disagree, I say that I disagree with that. Albert Einstein was not correct in explaining that light is packets of photons. Now, I do believe that light does travel in waves and in energy packets. Well, not particles, but it does have energetic properties behind the waves, and they have specific amounts. There's specific amounts of energy in different frequencies of light, and that I do believe, and those are fixed based on the frequency and the wavelength of light that you're dealing with. But I don't believe that they are photons. I don't believe photons exist. Something that travels as a photon or a particle does not make sense when you look at all the evidence when it comes to the double slit experiment and things like that have interference patterns. So I'm going to stop this video here. This one's just going to be on the photoelectric effect and how it is misinterpreted by quantum mechanics, and how that video that I just showed there is a more proper way of looking at the experiment, because low frequency light is able to discharge it by means of a flame. And the reason that the X-ray light discharges it is because the gas around the apparatus becomes charged positively and negatively, and that's what discharges the apparatus. It's not particles of light striking the metal like a billiard ball and then flying electrons out into open space, like if they were like just got impacted by like a rock or something. That's that's a very primitive way of looking at this. Looking at the gas around it being charged and it discharging the apparatus makes a lot more sense.